Okay, in this video, I want to build on what you already know, hopefully, about limits and limit notation, and I want to change it up a little bit, okay? So now in this video, instead of looking at the limit as x approaches infinity, or negative infinity, which we've talked about before, I want to look at as x approaches particular values, okay? So before, the question we asked was, you know, we saw a notation like this, limit as x approaches infinity of f of x. And we interpret this as, what are the y values doing as x gets really large in the positive direction, okay? So when we see something like this, the limit as x approaches 0 with this little plus symbol, we're going to interpret this as, what are the y values doing as x approaches that value from the positive side, right? And if we see this notation, we are going to interpret this as, what are the y values doing as x approaches 0 from the negative side, okay? So let's look at this function, just y equals, or f of x equals 1 over x, and let's do these, do the analysis here, okay? Again, this is asking me, what are the y values approaching as x approaches 0 from the positive side? So from this side of 0 to the right, okay? So what are the y values doing? Well, if you look at the y values and you trace the graph up, use a different color here, you trace the graph up, it's just going to keep going up. It's going to approach positive infinity, okay? So we're going to write that approaches positive infinity. You don't necessarily need to write the plus there if you don't want to. The next question is, what are the y values doing as x approaches 0 from the left? So from the negative side. As we get closer and closer to 0, x equals 0, what are the y values doing? Well, they're approaching negative infinity. They're going to go down forever, okay? So we can write this, that they're approaching negative infinity, okay? So the questions that we'll ask in related to this are, we'll first ask you to find the vertical asymptote and then ask you to describe the behavior around it. So in this example, let's do just that. We're given this function, x over x minus 2, and we want to find the vertical asymptote and then describe the behavior next to it, or around it, okay? So where's the vertical asymptote? Well, you can see it clearly here. Well, it's actually a little bit hard to see from the graph, but the function, we can see that if we plug in 2, we get a divide by 0 error. So the vertical asymptote is at 2. All right, we'll sketch that in as a dotted line here. So at 2, we have a vertical asymptote. So what we will do to analyze the graph around the vertical asymptote is we'll go over here and we'll say, all right, what are the y values doing as x approaches 2 from the positive side? And then what are the y values doing as x approaches 2 from the negative side? Okay, so we will analyze both of those things and then we'll sketch it out. So, or write it out. So as x approaches 2 from the right, from the positive side, let's look at what the graph does. The graph is going up. As we get closer to 2 from the right-hand side, it's going up forever. Okay, so we would say that this limit approaches positive infinity. All right. As x approaches 2 from the negative side, so as x gets closer to 2 from the negative side, it goes down, similar to the last function. It goes down forever. Okay, so we'd say that that limit is equal to negative infinity. Okay, so anytime you see that notation, you're thinking, what are the y values doing when x approaches or gets close to some value from either the positive side or the negative side?